11.60. Reactant A with Ca0 is equal to 64 moles per meter cube flows through a plug flow reactor. Tau is 50 seconds. Reacts as follows. A gives R. Minus Ra is equal to 0.005 Ca raised to 1.5 and rate is moles per meter cube per second. So time is in second. This is moles per meter cube. So everything is in consistent units. Determine the conversion of A if the stream is a microfluid. So if it is a microfluid, it is usual ideal PFR is applicable here because they will move flow freely. Molecules will move freely. We have seen the concept of microfluid. So tau, our model, minus Ca0 to Ca dCA by minus Ra. So minus Ra is K Ca raised to 1.5. Okay. So minus Ca0 to Ca dCA by Ca raised to 0.5, 1.5. If you solve this, okay, this you can remove. This is not required. We have to solve minus Ca0 to Ca dCA by K Ca raised to 1.5. K value is known. So if you solve this, K constant you take outside, K tau and dCA by Ca raised to 1.5. If you solve with Ca0 to Ca and we have minus sign outside. So that you get here minus 1 upon minus 0.5 Ca raised to 0.5 Ca0 to Ca. Okay. So this minus sign is carried out. This becomes Ca raised to minus 1.5 if I take in the numerator plus 1. It becomes minus 0.5. So this minus sign divided by minus 0.5 and that can be transferred again in the denominator as Ca raised to 0.5. So Ca raised to 0.5 minus 1 upon minus 0.5 Ca raised to 0.5. So this minus minus becomes plus and we are not reverse the order here, maintained. So 1 minus 0.5 by Ca raised to 0.5 minus 1 by 0.5 Ca0 raised to 0.5. K tau. So here K is 0.005. Tau is 50 seconds. And this 0.5 transfer on that side. So K tau and this constant 0.5. This you multiply, it is 1.125 and that is equal to, this is already transferred. So 1 upon Ca raised to 0.5 minus 1 upon Ca0 raised to 0.5. Ca0 is given as 64. Only Ca is unknown. So you solve this for Ca. You get Ca as 16 moles per meter cube. And Xa will be 1 minus Ca by Ca0. Ca is this value. Ca0 is 64 which is given. So that comes out to be 0.75. Fractional conversion is 0.75. Conversion 75%. Part B. Now it is macrofluid. So we have to use a non-ideal model. So minus dCA by dt Kca raised to 0.5. Again this is Kt. Okay. So this becomes 1 minus 0.5 Ca raised to 0.5. Now this minus sign I have used to reverse the order of integration from Ca to Ca0. In earlier case I have not replaced. That is your choice. Anyway, the sign change or you do not change the sign. If you carry out the further simplifications or computations properly, there is absolutely no problem. So integral is 1 by minus 0.5 Ca raised to 0.5. With this minus sign, I have reversed the order. Ca0 to Ca is written as Ca to Ca0. So this upper limit Ca0 that comes first, then lower limit is now Ca. K is 0.005, Ca raised to 0.5, that is also known T. So we'll first multiply by Ca0 raised to zero point 0.5 throughout to get our Ca by Ca0 term. Okay. So here if I multiply by Ca0 raised to zero point 0.5 and second term Ca0 raised to 0.5, if I multiply, this gets cancelled out. 0.5 taken outside, 1 by 0.5 is written as 2, exactly similar to what we have done earlier. Process is same. Here we have multiplied, this is 1.5, and then when order was 0.5 we have divided, that is the difference. So Ca0 by Ca raised to 0.5 minus 1, this 0.5 I have taken out as 1 by 0.5 and 1 by 0.5 is 2, that is equal to K 0.005, Ca0 raised to 0.5, Ca0 is 64, so square root of 64, that is 8T. Okay, so Ca0 by Ca raised to 0.5 minus 1 is this 2, we have to transfer on this side now. So if you solve this, this is simply 0.02T. Okay, so this can be written as, this you transfer on this side, 1 plus 0.02T. This is Ca by 0 by Ca raised to 0.5. So square both the sides, you get Ca0 by Ca, and here 1 plus 0.02T whole square. And we want Ca by Ca0. So Ca by Ca0 will be 1 by 1 plus 0.02T whole square. So this again same model equation we use. In this problem, E curve is not given to us. However, we have the information on tau, and that is given as 50 seconds. So as an approximation, we take t is equal to tau and plot this t in second. So this represents here 0.50 second. E is in second inverse and this is 1 by 50 second inverse. So that area under the curve will be 1. So with this we proceed. Ca bar by Ca0 at exit. Integral 0 to 50, 1 plus 1 upon 1 plus 0.02 t square. This we have already done. Ca by Ca0 is equal to 1 by 1 plus 0.02 t whole square. So this we have substituted. E is equal to 1 by 50. So this 1 by 50 taken outside, so we have written it as 0.02. And integral of 1 by 1 plus 0.02t whole square, we get it as minus 2500 divided by 50 plus t. So you can solve this, and after substituting the limits from 0 to 50, we get this value and multiplied by 0.02. Finally we get Ca by Ca0 as 0.5. So Xa, or you can write it as Xa bar also, will be equal to 1 minus 0.5, that is 0.5. So conversion is 50%.